In level 2, we will be solving projectile motion problems using the TI Nspire graphing calculator. So I will show you how to do that. You will be given the general equation for projectile motion, which is up here. And all you have to do is plug in the initial velocity and the initial height. So in this example, Mr. Wong is standing on top of a 25-meter high castle, and he shoots an arrow upwards with an initial velocity of 20 meters per second. So his initial velocity, V naught, is 20, and the initial height, since he's standing on a 25-meter high castle wall, that will be the initial height where the arrow will be released. So H naught. And so to write the quadratic function, we're just going to plug those numbers in the right place in the formula, and we get f of t equals negative 4.9 t squared plus v naught, which is 20 t, plus h naught, which is 25. And we're going to plug that into our graphing calculator, and so we turn it on and we go to graph. And remember, first we press tab to enter the equation, but remember that we can't plug in t's, we need to use x's. So it's going to be negative 4.9 x squared plus 20x plus 25. And if you press enter, you can't, well, I'm in the standard window right now and I can't see the top of this parabola. So there's a couple different strategies for how you can see the whole graph. You can zoom out, you can try zoom fit, but remember that in a real life example like this, we care most about quadrant 1, where we have positive x values, because remember that x represents time, and time can't be negative, so we don't need negative x values, and the function represents the height of the arrow, and pretty much we're going to be dealing with positive heights unless we're going below sea level, which in this case we probably will not be. But remember, the initial height is 25. The height tends to go up pretty high, but if you think about the time that it takes for something to go up in the air and come back down, it's not usually a long time. So our x values may not need to go out very far. In fact, we can see where the parabola comes back down already, but we just can't see the top of it, so we need to go up higher. So if you like to do zoom fit or zoom out, whatever you like to do is fine, but I'm just going to play around with my window settings. I know that I don't need negative values of x, because that would represent negative values for time, and that doesn't make any sense. 10 seconds is enough because I know that I can already see where the parabola hits the x-axis. So I'm going to play more with my y min and y max. It's okay to have your y min go a little bit below 0 so you can see where the graph is hitting the x-axis, but we're going to need to go up pretty high for y max. And if I'm sure Mr. Wong is shooting an arrow from 25 meters high, I at least need to be up that high, probably quite a bit higher than that. I don't know how high an arrow would go, but I could guess maybe 100 meters. And so I guess, and I see if I can see it. And that worked. I could see my whole parabola. I probably didn't need to quite go up to 100, but as long as I can see the top of the parabola, I'm good to go. So now the question is, when will the arrow hit the ground? And the arrow will hit the ground when it reaches a height of 0, and that's when the graph hits the x-axis, or when the function equals 0. So I want to find the x-intercept. So I do menu, window, or analyze graph, and 0. And I move to the left of it, press the middle button. I move over to the right, press the middle button, and there's the point, and I can't see it very well, so I'm just going to move it up a little bit. Or maybe I'll move my function out of the way. It's kind of in my way. I'll move it way up here. And so about 5.085 seconds is when the arrow will hit the ground. So when time equals 5.085 seconds. What is the maximum height that the arrow will reach? Well, now we're going to find the maximum point on this parabola. So I do analyze graph, maximum, and I want to find the maximum point, so I move this line to the left of the maximum point for the lower bound. For upper bound, I move it to the right. I press the middle button, and there's the maximum point, which I'll move up a little bit. And remember that your independent variable, which is your x value, represents time, and your dependent variable, your y value, represents the height of the arrow. So the function is a function for height. That's your y value. So the maximum height that the arrow will reach is going to be the y value, 45.4 meters approximately. So 45.4 meters. And at what time does the arrow reach its maximum height? Well, that would be the independent variable, or the x value, about 2 seconds, 2.04 seconds. And when will the arrow reach a height of 40 meters? To find this exactly, some people like to try and use trace, but that's not going to give us an exact value. So a better thing to do instead of doing that is do tab to get your function. Why is this not showing up? To get your where you enter your function, and in f2 of x, you're just going to put in a horizontal line, y equals 40. So you just enter 40. Press enter, and it gives you a horizontal line that, and now we can find the intersection. So we go to menu, analyze graph, and we want the intersection. There are two places where this graph hits a height of 40, so I'm going to have to find both intersections. The first one is right, it's misbehaving there. Okay, so at about 0.99 seconds it reaches a height of 40. And then I do the same thing again, analyze graph, intersection, and I have to go click to the left of it, click to the right of it, and I'm going to move it because we can't read it. And it reaches a height of 40 at 3.09 seconds.